Dear students, in this video we will discuss the linear hashing technique. It is a part of the dynamic hashing technique. So in case of the linear hashing, we are considering a family of hash functions h0, h1, h2, and we are following the new fashion for splitting operation of different buckets, that is the round robin. So directly avoided in the linear hashing by using the temporary overflow pages, adding new page whenever any overflow occurs with which page that overflow occurred, adding the new page there and inserting the new element into the new page, then splitting the following pages, right? So in this way we are following the round robin fashion. So we will discuss in detail with the help of an example. The linear hashing is a dynamic hashing technique. So this technique handles the problem of long overflow chains. As we discussed in the open chaining method, there we faced one problem with the search operation. As the number of nodes increased in the overflow chaining technique, the search operation takes much time, right? That particular problem may not be repeating in the linear hashing technique, even though we are following the addition of new pages to the existing node, right? We will discuss in detail with the help of the function. So in this one we are using the hash function like this: hi of key is equal to h of key mod 2 power I n, here n representing number of initial buckets, right? H is some hash function like h0, h1, h2. So this h0 may contain say 2-bit representation, h1 3-bit representation of individual bucket positions, h2 4-bit representation, like that. So here hi plus 1 doubles the range of hi, right? So it is same as a doubling. So 2-bit doubled with the 3-bit, 3-bit doubling with the 4-bit, right? In the same way hi plus 1 doubles the range of hi. In case of the linear hashing, the main idea or what are all the levels we are considering during the any round or the implementation of linear hashing. During the round, the number level, only hash functions h level and h level plus 1 only will be considered. The remaining all will not be considered. So with this h level, if any problem occurs, adding the new page to the h level, then splitting the h level plus 1, right? So in that way we are considering or implementing this linear hashing technique. The buckets in the file at the beginning of the round are split one after the another, right? One by one from the first to the last bucket. How many number of buckets we have in the linear hashing representation? Initially, if there are 4 buckets, we will discuss, we will divide the first bucket, right? Then second bucket, third bucket, and fourth bucket, again go to the first bucket. In this way the round robin fashion we are following, right? One by one from the first to the last bucket, thereby doubling the number of buckets, right? So after reaching all the buckets splitting operation, after completion, then we will double the number of buckets, right? This is the overview of the linear hashing. So in this one there are 3 colors: red, green and blue. So the red color representing buckets to be split. These are not considering now. These are the buckets that right now splitting. The green color representing in the next time whenever problem occurs with this red color, then we will split the green color. So the next pointer pointing here means that after adding or distributing the elements, what are all the buckets pointing by this red color, right? The next turn will be with the green color buckets, right? So now in a round robin fashion, whenever any problem occurs with the last position, that is the blue position, adding new page to this blue color buckets, inserting the element there itself, then split the red one. If the red one suffering with that problem, add the new paste to this bucket and split the green one. If the green one suffering with this problem, then add new paste to this green and split the blue color. In this way, in the meanwhile, at the time of following this splitting of adding the new paste, we will increment the table size, right? Doubling the table size, right? So we will discuss in detail with the help of the example. So in case of the linear hashing insertion operation, we have to consider the following points. Find the appropriate bucket. Here also, what are all the elements available in the input? Those are all should be converted into the binary form based on the hash function family H0, H1, H2, whatever the hash function we are considering. So depends upon that the number of least significant bit we have to consider, then find the appropriate bucket. If that bucket contains the empty cell or the room to insert the new element, then we can insert there itself. If that bucket is full, add overflow page and insert the data entry. That means adding the new page there itself and insert the element into the new page. Then split the bucket which is pointing by the next pointer. After splitting that bucket, then the next pointer will be incremented. That means it should point to the following bucket. So here we are following the round robin fashion. That's why this next always moving from one bucket to the another bucket based on with which bucket we are facing the overflow problem. Here, even though we are following addition of new paste to the existing current bucket, here there is no chance of repeating the same problem which we faced in the open hashing technique. That long overflow chains may not be created in this linear hashing technique. Right, see the example. This is an intermediary case given. So already all these elements inserted. Here the level we are considering level 0. N value is equal to 4. Here 4 combinations are there, 0, 0, 0, 1, 1, 0 and 1, 1 and H0 we are considering, right? So for the distribution of the elements, and the bucket size is 4. There are 4 rooms in individual buckets. The last 2 buckets already occupied all the rooms, right? Filled all the rooms. And the first 2 buckets contains a single room, empty position. We can insert one more element into the first bucket and the second bucket also. Now here we are trying to insert the element 43. So this 43 should be converted into the binary. The binary form of 43 is 101011, right? So all these elements already following the hash function of 2-bit representation 0001 like this. So we should consider this 43 the last 2 significant bits 11, right? So definitely this 43 should occupy the 11 pointing bucket. So this 11 pointing bucket already contains values 31, 35, 7 and 11. There is no room to insert 43 here, right? It is a overflow case. As we discussed in the previous slide, whenever any overflow occurs, for that bucket we should add the new page. Have you identified here? For the bucket which is pointing by the this H0 index position, that is 1, 1, added the new page with the same number of rooms. There itself inserted the element 43. Then what we have to do? We have to split the following bucket, right? So with this consideration of up to 1, 1 of H0, what would be the following bucket? Definitely 0, 0. So this 0, 0 pointing H0's 0, 0 pointing bucket should be divided. So here 32, 44 and 36 distributing and dividing like this, right? Now in case of this division, this page, whatever the H0 we are considering, that one is doubling with the 3-bit representation as H1, right? So one more, not showing all these possible cases, like the next 1 0 1 with 0 1, next value 1 1 0 and 1 0, these are all not showing here, right? Only representing the first option, first 1 0 0 0 0. So this new bucket with the representation are pointing H1 hash function 100 H0s 00, right? So now we have to consider the 3 bits like 0 0 0 0 1 0 1 0 for the distribution of this dividing pace, the dividing bucket, right? So 32 occupying 32's last significant bits, 3 bits are 0 0, that's why occupying the first phase. For 44 and 33, last 3 bits are 100, that's why those two occupying the last position, right? So let us insert 50 here. To insert the 50, the binary form of 50 is 110010. So now we are considering 3-bit representation, right? So last 3 bits are 0 1 0, definitely it should occupy 0 1 0 0 1 0, right? But 0 1 0 pointing bucket already filled, it is full, there is no room to insert the element 50 there itself. Now adding the new page to that and inserting 50 there, right? After inserting 50, then we have to split the following bucket. So splitting the following bucket, which is pointing by H1's index position 0 1 1, right? Then that bucket is splitted and distributed the elements, right? This is all about the insertion operation. In case of the search operation, to find the element 44, where that 44 available, we have to follow the same method. Same method means convert 44 into binary form. And right now our linear hashing representing H1 hash function, right? So H1 pointing 3 bits. So for this 44 also we should consider the last 3 bits 100. Definitely 44 will be available in 100. Yes, here there is a 44 available in 100. Then what about 9? Where is the 9? 9's last 3 bits are 0 0 1, right? So 9 pointing here 0 0 1. So in this way we can find the any element with the help of linear hashing technique. Alright, this is all about linear hashing. Thank you.